Last time, we stopped the division into primitive and complex data types. Primitives are some numbers, tuples, bools, chars, while complex types are strings, arrays, lists, and so on. Now, let's take a look at a couple more data structures to finish the systematization. To explain stacks and queues, let's take a look at these two examples. First, imagine we are waiting in a queue in shop and we have a cash register and few people waiting. Person 1 has arrived first, then person P2 has arrived, and person P3 joined queue the last. Since person 1 has arrived first, he will first finish and leave the place. Data structure that follows such logic is called queue. Due to that logic, queue is officially first in, first out data structure. Further, imagine we are arranging plates in the kitchen. We'll put the plate 1 first, then stack the second plate to it, and third to the second one. We put the P3 plate, the last, into the pile, and it will be taken first. That is an example of stack data structure. Due to logic it follows, stack is less in first out data structure. Let's now transform these two real life examples into the following form. If we have a group of numbers, as in the last video, for example, 1, 2, 3, 4, as mentioned, it's usually considered an array or list. But in terms of queue, we also have some group of elements, but we can only have access to the first one. We can access it and remove it. Or, in terms of stack, we can only access to the last one and remove it. In the past, we had mobile phone keyboards like this. If we transform it like this mapping, map 1, map 2, two characters it represents, and so on, and 9 to character it represents, it's actually the dictionary data structure in C#. Elements 1, 2, and so on, up to 9, are called keys, and lists of letters are values in dictionary. Note that key doesn't have to be only number. It can be char, string, tuple, list, and so on. The only constraint for key is that it has to be unique. Values can also be of different types, but values can contain duplicates. Now let's talk about sets. Last time we considered structures like 1, 2, 3, 3, 1. Sometimes it's important to consider unique values only. In math, such data structure is called set. In C#, that is a hash set. We will discuss the details of it in the future. Now, let's talk about graphs. You must have met with data structures like these. Both of them represent graphs, but the second one is more specific, and it's called tree because it satisfies some additional conditions. For example, there are no cycles. Further, if the tree satisfies some additional conditions, for example, like here, that a value inside each node is greater than all children. It's called heap. So this one is also graph 3, but it's heap. Please note that in different materials, you may have met with division of topics like arrays, graphs, trees, heaps. But it's important to be aware that they are not all different, and trees and heaps are actually special cases of graphs. Now we have the expanded systematization. Types called primitive last time are actually value types in C sharp. They keep just a simple value. Complex types from last time are actually reference types in C sharp. Since they contain a group of elements, they cannot keep just simple value. They keep the reference in memory to our group of elements. Of course, more details on this topic will be discussed in the future videos, both on concrete examples and later inside the medium level course. Notice that we have also linear and nonlinear data structures. Linear data structure means that elements are arranged in sequence. For nonlinear, it's not clear either the order of arrangement for dictionary and hash set, or there could be multiple predecessors or successors, like in graphs. Now, we have an overview of data structures in general. Some concepts have been discussed in terms of C sharp as well, and we will dive deeper into most of the mentioned data structures as we solve the lead code tasks in the future.